Hi everybody, this is Algebra 2 Lesson 6, and this lesson covers equations with decimal numbers and consecutive integer word problems. Alright, so our first example is an equation with a decimal, and this is a really easy part of the lesson right here. We could solve this equation just like this, but what I want to do is try to get rid of these decimal numbers. If I multiply everything on both sides of the equation by the same amount, it doesn't change the equation. So all I'm going to do is count my decimal places. I have 1, 2, 3 right there. I've got 1 right there, and I've got 2 right there. And I'm going to go with the highest number, so 1, 2, 3, and I'm going to multiply my whole equation times a 1 with that many zeros. So I'm going to multiply this whole thing times 1,000. When I multiply times 1,000, that means I'm going to move my decimal 3 spaces for every number. So that would be 3x. If I move this one 3 spaces, that means I'll have to add 2 zeros, so plus 400, yep. And then this one, 1, 2, 3, yeah, 400. This one on 1, 2, 3. Equals 2050. So you just move the decimal the same amount of places on all of them. Now this is a little easier to solve. I'm going to do minus 400. And I'm going to get 3x equals, let's see, 0, 5 minus 0 is 5, 1650. Then I'm going to divide by 3. And 1650 divided by 3. 3 times 5 is 15 minus 1. Bring that 0 up, and x equals 550. And that's the answer to that. And it's so much easier than messing around with all of those decimals. Alright, pretty simple concept. Alright, so the next part is about consecutive integer. Nope, this is another decimal one. Never mind. The students found that 0.015 of the teachers were either brave or completely fearless. If 300 teachers fell into one of these categories, how many teachers were there in all? So if I drew a diagram of that, right, this whole thing is teachers, and this little tiny piece is our brave, okay, and that's 300, and it's 0.015. So we're saying 0.015 of the teachers, right, times the teachers, is 300, okay, 0.015 is the 300. Alright, so what I have to do here is divide by 0.015, because that's multiply, so I do the opposite. Okay, and then we're going to get t equals. Now you can use a calculator for this if you want. 15 times 2 is 30. And then I'm just going to bring up all of these zeros. And the answer on that one should be 20,000. Yep, there's that. So if you need to draw a little diagram like this when you're working these problems, sometimes that's helpful. Alright, an analysis of the old woman's utterances showed that 0.932 were victual if she spoke 2,000 times during the period in question. How many utterances were victual? So we're going to write that. 0.932, that's going to be almost all of it. So this is 0.932. And those are the, right? And so this part right here is going to be not the, not, we'll just write not. How many were not? That's what we have to try to find, is this piece right here, okay? So if you took 1, which is this whole thing, okay, which is 2,000, if that's going to be 1, and we subtracted 0.932 from it, what are we going to have left? So what is this part over here? And it would be 68, I think. So we just subtract 9 9 minus 3 is 68. Yep. 0.068 is going to be right here. So that's 0.068. So that means 0.068 is the knot. Okay. So if you said 0.068 of, which means times, 2,000 is our not victual, right? So I'm just going to use n. So that means we just multiply because they're on the same side of the equal sign. Oh, I should have done that the other way. It'd be so much easier. Right, so you just drop these zeros, and then you say 2 times 8 is 16, carry the 1, 2 times 6 is 12, 13, and then we count our decimals, 1, 2, 3, 1, 2, 3, and the answer should be 136, our not victual. Alright, easy peasy. So what you do for these is the whole thing is 1, and you just figure out what the piece that you're missing is. Alright, consecutive integers. Find 3 consecutive even integers. Now consecutive means numbers in a row. Count like 1, 2, 3. They're going in a row. But if we had even integers, that would be like 2, 4, 6, 8. Okay, so we need 3 consecutive even integers. So we're going to start with n. That's going to be our first integer. Now to get to the next even number, let's say that n was 2, right? To get to the next even number, we would have to add 2, right? The next one would be n plus 4, right? So if this was 2 and we added 2, we would get 4. And we added 4 and 2, we would get 6. And then we would get 2, 4, 6. Keeps them consecutive. We don't know what they are. They could be 10, 12, 14. They could be 20, 22, 24, right? So those are the 3 numbers. So our first is n. Our second is going to be n plus 2. And our third is going to be n plus 4. Okay, we have to figure out what those are. All right, such that 5 times the sum of the first and the third. So if I've got 5 times the sum of the first, which is n, and the third. So to n, I'm going to add the third. The third is our n plus 4. Okay. Is 16 greater than 9 times the second? I'm just going to write 9 times the second. My second is n plus 2. And it's saying that this is 16 greater, right? So our first part is 16 more than our second part. So that means we have to add 16 onto our second part to make them even. Now we're going to rainbow. Actually, well, I'll just do it this way. 5 times 4 is 20. 9n plus 9 times 2 is 18. This one right there. Plus 16. Now I'm going to combine like terms. So 5n and 5n will be 10n plus 20 equals 9n plus 16 plus 18. 14, 34. Okay, now I'm going to put my n's together. And I'll have 1 n left over here. Plus 20 equals 34. Now I got to do minus 20. I'm going to get n equals 14. So if n equals 14, right, our first is 14, n plus 2 would be 16, and n plus 4 would be 18. So how you write your answer is going to be 14, 16, 18. Those are our 3 consecutive even integers. To check it, you could go back and put those numbers in where your n's are. All right, let's do another one. Find 4 consecutive even integers, so I need 4 of them. Right, so I'm going to have my first, my second, my third, and my fourth. Okay. And they're consecutive integers. Okay, these are not even. It just says consecutive integers. Let me double check and make sure I typed that right. Consecutive integers. This means in a row. So the first one will be n. The second will be n plus 1, n plus 2, n plus 3. So if we were thinking like 1, 2, 3, 4, right? So we got n. 1 and 1 is 2. 1 and 2 is 3. 1 and 3 is 4. Okay. Alright, so we got 5 times the sum of the first and the fourth. So the sum of the first be n, and the fourth is n plus 3. And we have to multiply that times 5. 5 times the sum of the first and the fourth is 1 greater than 8 times the third. So we're going to put 8 times the third, and the third is n plus 2. Okay, and it's saying this is 1 greater than the other side. So to make them even, we're going to have to add 1 to our second side there. Now we're just going to solve. I'm going to put these and do 2n. And then 2 times 5 will be 10n plus 5 times 3 is 15 equals 8n plus 8 times 2 is 16 plus 1. Now I have to add my 16 and my 1 would be 17. I'm just going to erase and do that. Okay, and then I got to get my n's together. And I'm going to get 2n plus 15 equals 17. Now I have to do minus 15. And you get 2n equals 2. Divide by 2. N equals 1. So that means my answer is going to be 4 numbers with the first number being 1, right? My first integer is going to be 1. So it would be 1, 2, 3, 4. That's the answer. Okay, so that's how you'd write the answer. Alright, go ahead and, it's not cooperating, work those practice problems, and I'll come back and work them for you. Alright, so hopefully you pause the video to work these. There's only 2 of them. The first one says, the astronomers found that 0.017 of the stars examined were red dwarfs. If there were 29,000 stars were examined, how many were not red dwarfs? So if we drew a little diagram for that, this is going to be a tiny little fraction, and that's 0.017. Alright, so to figure out what the rest of this is our dwarfs. Okay, this is our not. Okay, and this is the whole thing, which would be 29,000. Okay, so we've got to figure out what part our knots are. So if one whole, right, we're going to subtract 0.017. So that would be 9. 10 minus 7 is 3. That would be 8. 0.983 is our not. Okay, so that means 0.983 of the 29,000 stars is our not red dwarf. So 0.983 of means times 29,000 is our number that we're looking for. So all we have to do right here is multiply, and I don't mind if you use a calculator for these. Let's see if I can do it on my own here without my calculator. 9 times 3 is 27. 9 times 8 is 72. 73, 74. 81. 88. 2 times 3 is 6. Drop 3, yep. 2 times 8 is 16. 9 9 is 18. 19. 10. 6 and 8 is 14, 15, 18. That's a big number, and then I'm going to move over 1, 2, 3 decimal places. So 1, 2, 3. And I should have 28,507 stars. And that's the answer right there. Alright, so for part B, find 3 consecutive even integers such that okay, so we need 3 consecutive even integers. So our first is going to be named n. Our second needs to be the next one up even from that, so it would be n plus 2. And then our third is going to be n plus 4. Okay? Okay, such that 3 times the sum of the first and the third. So I need the sum of the first and the third. My first is n, and my third is n plus 4. And we're going to multiply that 3 times. Okay? Is 84 less than 12 times the second? So I'm going to do 12 times the second, which is n plus 2. Okay, and it says that this side, this first side, is 84 less than the other side, so that means I got to subtract 84 from that side, the second side. All right, now I'm just going to try to work this. So 3 times n would be 3n, and then another 3n right there, and then 3 times 4 is 12. Then I'm going to do 12n, and then 12 times 2 is 24. Okay, now I'm going to combine like terms on either side, so that would be 6n plus 12 equals 12n, and then 84 minus 24, negative 60. Okay, now I'm going to try to get my n's together, so I'm going to do minus 6n, and I'm going to get 12, actually I'll write it up here, 12 equals, 12 minus 6 would be 6n minus 60, so I'm going to do plus 60, and I'm going to get 72 equals 6n divided by 6. And let's see, I'm going to get 12. 12 times 6 is 72, so n equals 12. Now 12 is not our answer. 12 is just n. I need n, and then I need the next one that's even up, and the next one that's even up from there. So it'll be 12. And the next even number, 12, so our n plus 2 would be 14. And then our third one is n plus 4, so 12 plus 4 is 16. 12, 14, 16 is the answer to that one. All right, that is it for lesson 6. Thanks for watching.